right, so flip over to that screen, slide 2. Actually, what I'm going to do is, hang on one second. There, that's what I wanted. All right, so as we look at slide 2, all of these graphs that you see are linear. And if you look closely over here on the left-hand side, all of those equations are the equations for each of these lines. So y equals x. See how this little circle right here is red? That's right here, this red line. Y equals negative 2x is this blue one. Y equals 3x plus 4 is the green one. 1/4 x minus 2 is purple. And then this one with the decimals is the, what's the orange one? How come I'm not seeing the orange one? Negative 2.6 plus 2.9. Oh, I'm not sure why the orange one's not in there. Oh, there it is. All right, so there's the orange one. So those are all linear. Take a look at the graph. Take a look at the equation. Think about what you might notice if I ask you to make an observation. Switch over to slide 3. Yeah, for this part, you can either follow along with me actually in the Meet, or you can do the slides on your own as I prompt you to move to the next one. So if you switch over to slide 3, please. Okay, and these graphs are non-linear. So if I go back actually to slide 2 and I look at the word linear, the root in there is line, okay? And then if I switch back to slide 3, these are non-linear. So take a look at the graphs here. Look at your equations. In a little bit, you're going to be asked about both the graphs and the equations. Okay, non-linear and linear on slide 2. Move up to slide 4. And I want you to write down, what did you notice about what a linear graph looks like and what a non-linear graph looks like. Take a moment and fill in those boxes. If you need to refer back to slides 2 and 3, you have the ability to do that. Again, I'm going to continue posting announcements through GoGuardian, just as a reminder for everybody to keep up with where we are at. All right, let's see what you guys are writing. Oh, I bet I didn't anonymize it. Let's see what you're saying about linear and not linear. Awesome. If you flip over to the Meets, you can see what you and your classmates are both writing. I know it seems like we don't particularly like to unmute, so I like to see what you are showing, and I want to show you guys what you are also writing. Again, if you're not quite sure about the answers to this, you can either look here at the screen in the meets, or you can look back at slide 2. You can see those graphs, those lines up here, and look at slide 3 and those lines here. Nicely done. Good responses for that, folks. That looks really good. All right, so let me move on and open up slide 5. I'm going to open up slide 5. Feel free to head to that one. And basically, it's exactly what you all wrote. Linear graphs are straight lines. Again, if you look at that root of linear, there's your line, and nonlinear are not straight. What I want you to do now is look at slide 6, and you are going to sketch your own graph. Slide 6. Okay, again, you can pick your color option, and you can either use this pencil, you can use that pencil to sketch your graph. So switch over to Desmos, and all you're going to do is sketch a line that is linear. Again, if you need to refer to it, look back at slide 2 and slide 3. Slide 2 and slide 3. Okay, nicely done. Again, if you are on slide, anything other than slide 6, I'm going to ask you to switch over there. All right, let's see what you and your classmates are doing for that. Oh, some of you are overachievers. Nicely done. Look at all those fancy lines. Perfect. Oops. Is this? Excuse me. Is this one line or 2 here? Whoever you are, you don't have to unmute, but just remember it needs to be a straight line, right? Like we saw on slide 2, anything that's not straight is not considered linear. All right, good work, team. Moving on to slide 7. So slide 7, we're going to now move into equations. And here's what I would like to remind you of. Anytime we're dealing with the graphs and equations today, feel free to go back and look at slides 2 and 3 and use those as examples for what we're going to do next. Okay? So what I want you to do now on slide 8, what I would like you to do now on slide 8 is you're going to sort these cards into 2 categories. And this is where you're going to use what you see on slides 2 and 3 to help you. See what you can do. So my suggestion is Move the nonlinear card over here. Maybe move everybody over to the middle. And then you are going to move the cards underneath either the linear, either the linear or the not linear ticket. That's what I would do. Okay, all you're going to do is grab them, drag, and drop. Use what you see on slides 2 and 3 to help you. I am going to set a 2-minute timer for you to try it on your own. And guess what? It's okay if you make mistakes. Do it. Go, 2 minutes. Okay, 1 more minute. All right, so that is our timer. Let's see what our classmates have put here as well. Again, no, I'm not going to do that. Again, there was no right or wrong answer in terms of you doing the best that you can, okay? But what I do want to point out is if we look back at slide 2, here's the examples of the equations. Y equals x, y equals negative 2x, y equals 3x plus 4, y equals 1/4 x minus 2, y equals all this business. Those are the linear ones. When I go here to slide 3, I've got y equals x squared, y equals the absolute value of x, y equals x to the third, y equals 3 divided by x. Notice anything in particular about the nonlinears compared to the linears? So let's go back to the sort. And this is where I'm going to ask you guys to offer up some ideas about what you put in under nonlinear and what you put under linear. So feel free to either click the little raise hand here in the Meet or type in the equation in the chat and which side you think it needs to go to. Go. Bryant. Correct. Y equals negative x squared minus 5. Needs to put in not linear. What's another one? Again, either click the little raise hand button in here or type it in the chat. What's another one that you put either in nonlinear or linear, folks? Safinas? Did you have your hand up, Safinas? Come on, folks. Oh, you put it in Go Learning? Oh, all right. Let me click open the chat. Yeah, where did you put that one, Safinas? Did you put that, are you talking about this one, right? Did you put it in linear or not linear? Yes, correct. Nicely done. All right, what else should we move? Come on, people. Look back at slide 3. There's lots of really good hints in slide 3. Serious lag. Lag. 1, 2, 3. Wowzers. All right, slide 3. Here, it's coming here shortly. Look at these equations over here. Okay. Should be able to look, maybe especially at those first 3. Now go back to slide 8. What should we move and where should we move it? Brian? Correct. Waiting. The question is, where else can we put these tickets, these cards? Go ahead, Bryant. One over X. Yep, correct. Y equals 1, Frankie. Y equals 1 over X is not linear. It actually, Y equals 1 divided by X. This is the graph of Y equals 1 divided by X. Okay, so anytime you divide by that variable, it is not linear. All right. What's another one? So I will give you another hint. There are 2 more that need to go in non-linear, and there are 4 more that need to move over to linear. Brian? Correct. No, Frankie. If this one's in nonlinear, it should be very obvious that there's another one to move over to nonlinear. This one right here. Yep. Correct. All right, there's one more in this pile that needs to move over to nonlinear. Go ahead. Mm-hmm. Good. So these other three, I don't think I can pick three of them at a time. These other three all need to go over to the linear section. Okay. Now, one thing to notice, these nonlinears, anytime you have an equation that has something different or funky, an exponent, a special symbol, it's divided by x, those are nonlinear. So take a moment to make sure that you have those all correct in terms of their location on slide 8. And then we're going to move into slide 9. All right, so slide 9 wants to know, did Mark do this one right? Mark actually put -2 divided by x in the linear pile. Is he right? And if you were following along with what we just did, you should know that answer. Linear or not? Yes or no? All right, so moving on to slide 10. Slide 10 is just the basic definition of linear equations. Anytime we have equations in the form of something called y equals mx plus b, those are linear. Anytime you see something with an exponent like x squared, if you divide by x, or if we have any special symbols, square roots, absolute values, or anything else, those are considered non-linear. Based on that, based on what we did in slide 8, on slide 11, I would like you to write a linear equation. Go. Slide 11. 30 seconds for slide 11. Thirty seconds. Slide 11. Go. For examples, you can look back at slide 2. You can look at slide 8 with the card sort. I think we need a little more time. I see some people moving back to previous slides to double check. Okay, again, we should be on slide 11, typing in an equation. And if you look at slide 2 and 8, 2 and 8. All right, let's see what you are putting in there. Yes, not quite done yet. This one's correct. Fancy, but yes, this one works. Depends on what I see with the rest of this one. Correct. If you're the one who did y equals x5 minus 10, that is linear. We do typically put the number in front of the variable, just as a heads up. Okay, $sign, get rid of the $sign. Really? All right. Thank you. Yep, y equals 2 is linear. If you just do y equals in a plain number, it's actually going to be a flat line like that. Great. Nicely done, folks. Those look really good. Thank you for fixing that one. Okay, so let's move on to let's move on to slide 12. So we're going to move into tables, and we're not talking about the kind of table that you may or may not be sitting at, but we're going to talk about tables in relations to equations and graphs. Okay, so moving on to slide 13. I would like you to, on slide 13, I know we haven't talked about it, we didn't do anything other than talk about lines and graphs. What I would like you to do is just try and put these 4 tables into the category of nonlinear and linear. So just like you did with those other cards before, put linear and nonlinear on either side, and then I want you to drag and drop these tables as to where you think they might need to go. I am going to give you a minute and a half to do that. Drag and drop. And you know what? Again, it's okay if you make a mistake. We're going to talk about it, but I would like you to put the effort to trying it on your own. So again, switch over to slide 13 in Desmos. And you're going to drag and drop those cards as to just do the best that you can and make your best guess. $20 seconds. Five, four, three, two, one. All right. Here's what I'm going to tell you. This one is nonlinear. This one is linear. This one is linear. And this one is not linear. So take a look at what you did, fix yours to match mine, and I will explain why it's linear or not linear. So when we look at tables, we do look for patterns, and we specifically look for patterns by either adding or subtracting, not multiplying and dividing, adding and subtracting. So if I grab one of these little pens down here and I ask myself, what's happening in the Y column in this one, I notice that these are all going up by 4. So this table is linear because it's increasing, adding 4 each time. If I look at the second one, what's happening on this one, you guys? What do you do to 10 to make 21 and 21 to make 32, 32 to make 43? We're adding 11, right? Add 11, add 11, add 11. Sorry, I didn't long enough to see that response come through. One other thing that I want to point out to you, I see it's actually almost 11 o'clock, but somebody earlier today noticed that this one was multiplying by 2. And while that's a great idea, and they thought this was linear because it multiplies by 2, it actually isn't. When you multiply by 2, it makes the graph not turn linear. It actually makes it look like, oops, where did it go? Oh, no, that's what I wanted. This is the table. The table for that one. It got swoopy. Okay. All right, so here's what needs to happen. You are actually, I'm going to end that because, whoops, I need to switch to that geezer. Yeah, plus 11. Thank you, Ben. So I'm going to stop this. Your assignment between now and Monday is to actually finish this Desmos. So you're going to do 14 through 21 in reference to all of the things that we've done here, and then head to your DUR and put a score on your DUR for how you feel about it. Okay? It is 11 o'clock right now. If you have any questions that you want to stay on and ask, feel free to do so. Otherwise, you are more than welcome to head out, and I will see you all back here on Monday.